Welcome to a lesson with Dr. Powell. Let's take a look in this video at a practice problem where we're using epsilons and deltas. We're taking a statement of a limit being equal to something, and we're verifying that that statement satisfies the epsilon and delta definition for a limit to hold or be what it is. Okay, so in this video, I invite you to pause it and work it out on your own, and then play it when you're ready to see the solution. And on your mark, get set, pause the video. Okay, now here is the solution. So the statement that we want to satisfy, it's a right-hand limit statement. So it starts similarly to in practice problem number 1, given epsilon greater than 0. Okay, this time we have a line with a slope of 2. Okay, a line with a slope of 2, and we're heading toward the point x is 2. Just from the right side though. And the y value at this point, that we're heading to is 0. Okay. All right, so we're heading toward this point, but just from the right side. So basically it's like what we did last time, but on the right. So given epsilon greater than 0, we can draw a little picture of that, some symmetric distance, y distance up and down from this middle line, y equals 0. So up epsilon, down epsilon. All right, so given that, there exists delta greater than 0 such that, so some distance, positive number representing a distance, such that if the x values, that's a 2, okay, so such that if the x values are just a little bit to the right of 2 but less than delta, how do we represent that and not equal to 2? So that would be, just x minus 2 can't be 0, and it's going to be less than delta, and I will omit the absolute values. The absolute values would tell me that I can be on either side. This tells me I'm only on one side, in particular the right side. If I was doing something with the left hand limit, I would have a 2 minus x. But in this particular case, I have an x minus 2. This is because if x was over on this side, 2 minus x is positive. When I'm over on this side, x minus 2 is positive, and I want it to be a positive value to represent, that I want that distance to be greater than 0 and less than delta. Okay, such that if that is true, then the distance of the function output, the y value of the function output, minus, we're heading towards 0, 0 is going to be less than epsilon. Okay, and in the picture we can put an f of x. So like the previous problem, instead of saying there exists delta such that if, we're going to actually find out what delta is. Okay, so right here we're going to find out what delta is. So we can write let delta be equal to something, then if this, then that. And that's a statement of the limit holding. Let's just find out what this delta is in terms of epsilon for this given epsilon situation to verify that such a delta distance does exist. Here we can kind of see that, again, by symmetry, going this way and that way. Point of exit entry on either side is the same, except we're only focusing on the right. So, but pretty much it's going to be the same number. On the right, the point of exit entry, that would be perfect for a delta value, because if you know if you're in here, right, the x values are in here, you're going to be satisfied. The distance between f of x and 0 is going to be less than epsilon as desired. We can see that in the picture. So we just need to verify what such a delta would be right there. Well, we know we're going delta over, and we've gone epsilon up. And since the slope is 2, this is a straight line with a slope of 2, we can kind of think, in a triangle, delta and epsilon rise over run. Epsilon over delta is equal to 2. So what would delta be? Well, you can see that delta is going to be, so if you can kind of think delta coming up here and the 2 coming down there, swapping places, multiply both sides by delta, divide sides by 2, you're going to end up getting delta is equal to epsilon over 2. Okay, so we can say, and that makes sense. Delta should be 1/2 of epsilon, right? Delta is 1/2 of epsilon because the slope is 2. You can even visually see that without even thinking about the algebra steps. I mean, always think about things intuitively. Make sure it makes sense to you. Of course, delta is going to be 1/2 of epsilon because that slope's going to be 2. This is twice as much as that, right? Okay, so epsilon's twice as much as delta. Delta must be epsilon over 2. So let delta be epsilon over 2. Then if that, and this will work, how do we know it works? Well, why do you know that this is the right delta? Because of the picture and this slope condition that we got from the function itself, if this is f of x. Okay, so that concludes the solution explanation of question number 2. Thanks for watching.